Hello, Whittier High School future students and parents. First off, I'd just like to introduce myself. My name is Steve Swanson, and I'm here to talk to you today about the STEM Academy program at Whittier High School, what it offers, what it entails, and what it is. I have a presentation for you. First, I just want to talk a little bit about STEM. STEM, I think a lot of you already know what it stands for. It stands for science, technology, engineering, and mathematics. So here's the science part. What does it entail here at Whittier High School? Well, STEM Academy does have all these things, but specifically, class-wise, you'll be given a specific science class and a specific engineering class for all 4 years. Um, Math itself over here, the math part is actually depends on the student. So I would tell you right now that I would say the average student freshman year starts in geometry, although there are some that are in algebra and some are in algebra 2. But I would say geometry is your average student in STEM Academy freshman year. So because they're in different levels, we don't assign a math class a specific STEM Academy math class. Though there are plenty of math in the classes science and engineering that apply this math, yes, but the actual class just depends on your student. Science-wise, every year there's a science class, and I'll talk about those in a minute, and engineering class as well. So what does the technology encompass? There's a lot of technology in the science and engineering classes. I know I can speak for the engineering classes a little bit better though, but engineering-wise, there's a lot of technology. We have everything from small tools like soldering irons, saws, and pliers, and all kinds of tools. We have specialty tools like we terminate the ends of Ethernet cords and whatnot in my digital electronics class. We have larger machines. We have small CNC machines. We have larger CNC machines. We have laser cutting machines that actually cut using a laser. So there's a lot of technology students are introduced with. And I can go on and on about the robotics and the programming and the small computer coding that we do and all kinds of stuff. So lots of technology. But classes, definitely engineering and science, those are the two classes we're going to give, but they will definitely be exposed to technology right here because of all the technology we have, but also mathematics, obviously because of their class that they're going to be taking in math. That's not part of STEM Academy, it's just their own math class that they need, but also exposed in math in both of these courses that are part of the STEM Academy. So let's go on to what else STEM Academy is. So STEM engineering. So STEM Academy, it's an engineering program at Whittier High School. My email is here at the bottom if you need to email me, steven.swanson@whittierunionhighschooldistrict.org. So that's WUHSD.org. Go ahead and pause this video and write that down if you need to. I would like to add that this was an old palette that I had some students tear apart, put it together with some backboarding wood, and then they laser cut these letters right here, the STEM and engineering part. They just laser cut them, painted them, and then laid them there just for like a cool picture to have. So I just want to let you know that is something I actually had students build, and I just went out and took a picture, and you can see my feet there at the bottom. So this is one of the many things we build in engineering. Just for fun, literally. This wasn't even an assignment. Is STEM Academy for you? Do you like building things, programming, working in groups, learning new things? Those are definitely things we do, and a lot more. What do you want to be? A mechanical engineer, a civil engineer, an electrical engineer, a machinist, other STEM fields? There's tons of science courses, biology, chemistry, physics, so there's lots of stuff. So anything STEM related, this would be a place for you. Currently STEM class, these are current STEM classes that we've had. Principles of Engineering for freshmen, Introduction to Engineering Design for sophomores, and Digital Electronics for juniors. Because STEM Academy is only going into like our 4th, 5th year now, we're actually starting to add the last class, which you'll see here in a second, coming up here next school year. So there'll actually be a senior class as well. And in the future, because it's still expanding, we're thinking about having a second, right here, Digital Electronics, a second junior class. So students can kind of choose one or the other, whether they want to do digital electronics or maybe computer machining. So we're looking into that too. So we're constantly growing and expanding. Future STEM classes, like I said, we're looking at that computer integrated machining course as an alternate junior class, so students can kind of choose whether they like the electronics programming part or the machining part. And then all students have the opportunity to take the senior class, Engineering Design and Development. And that's where they build a large project all school year long in a team. So it's a really cool class. And that's going to be starting next school year, the 2021-2022 school year. So next school year. What does STEM Academy offer? So this is just some things I put together. Additional STEM Academy field trip only. So we actually have field trips just like any other program. There's other programs at the school. There's a Puente program. There's the CCA, Cardinal Computer Academy. There's different academies and stuff like that that offer field trips. We're no different. We almost have like one big one per year, per freshman year and whatnot. I think the freshmen, these are not in order, but I think the freshmen do the Knott's Berry Farm Engineering Day one. And then the NHRA drag races for sophomores in California Science Center. I think we do that actually freshman year as well, so we have like a couple of field trips there. And we do career and company visits whenever we can. We have specialized core classes. Robotics club, we have that. We actually compete against other schools and whatnot. Grade checks. So this is where we go around and we check their grades and try to keep up on top of them and make sure their grades are where they should be. We're aiming at all A's, right, for our students if they're going to be in the STEM field. Access to computer lab and equipment at lunch and after school. So I have a huge computer lab with a bunch of machines in it and all kinds of stuff. And certain days of the week during lunch they can come in, and also after school as well. So that's available to them as STEM Academy students. Let's start with the classes. Freshman year, Principles of Engineering. What will they be doing freshman year? What they will learn: machine efficiency, electronics, solar energy, hydrogen fuel cell, material stress, building, bridge building. I'm going to stop there for just a second before I continue. I just want to let you know all of these things on the left and all of the things on the right. And pretty much every topic in our class, we physically make things. That's why it's been a real challenge this year being online. I've tried to send some kids home with some kids and they can make some stuff, but it's nowhere near what we normally do in a school year. So when we get back, it's going to be, the kids are going to see the full fledged of what we do here in STEM Academy. But as far as everything goes, we make all this stuff. So machine efficiency, we test the efficiency of machines. We actually build the machines, test them, and check their efficiencies. We make electronics. Solar energy, we have solar panels and we test them. We go outside and test them. Hydrogen fuel cells, we have hydrogen fuel cells. We splice the hydrogen and oxygen and then run a car that they build and run it off of it. Material stress, we build things and stress the materials and see the breaking stress on them. Bridge building, we build bridges and test those as well. Fluid power, statistics, basic physics, learn math, Excel, PowerPoint, Word, robotics, programming. These are all things, and we do a lot more than this. There's soldering and all kinds of stuff. I would bore you by going on and on all day about all the things we do. Robotics. So here's just some robotics pictures of students working on some robots that they were going to do in a robot fight. And here's a video of the robot fight on the left side. And this is we actually created a rule that they can't create robots this big because this one seemed to be a little bit overpowering. So every year we change the rules a little bit. We talk at the end of all the fight of what rules they'd like to see implemented for the next school year. This one's called a Mario Kart fight, where students put balloons on the back of the robots and try to pop each other's balloons. And you can see this one's popping one right here, right now. It just did. Over here is the bridge building where we're checking the stress on the bridge, and I think it breaks here, yeah, and it checks the force of what they break it at. Freshman year, I mean those were all freshman year classes. Sophomore, Introduction to Engineering Design. This one's specifically drafting, drawing, computer-aided drafting, drafting by hand and on computers, 3D printing, laser cutting, stuff like that. So making things and designing things. It's basically the design process, including drawing and drafting and 3D printing and making things. So it says mechanical drawings, drawings in 3D, 3D printing, problem solving, design process. These were all things, by the way, the last screen as well. And this screen, these are things students have made. This was a puzzle they made. They drew it in 3D and assembled it in 3D. Then they build it in real life. Digital electronics is a junior class. And this one is basic electronics, soldering, integrated circuit design, breadboarding, and programming. So this is the very first project they do. It's small, and it's a 5x5 timer where they make this light blink. Then they get into projects like this one here, where we get into larger design electronics, designing things to do specific tasks. This is one right here, a student made right here, but I usually get on students and try not to make them where they make the wires so messy. I usually try to make them much more neater than that. In digital electronics, we actually build the electronics in Minecraft as well. Here's one where students had to make they made a calculator in Minecraft. So it looks like just right here, like there's just a magical calculator right here. 1 + 0 = 1, right? Well, there's somebody in here in this world running switches, and those switches are actually recalculating like a computer inside. To try to show you the vast wiring needed to make that happen, I'm just going to pause that right here. This entire field right here on this right side, that's all electronic wiring. These little red paths and all these little bridges and stuff are so wires can cross over other wires. This is a gigantic field of electronics to make that happen. In fact, this wall, what you see on the left here, that's this on the far right. So you don't see it from behind. I don't remember if this is exactly the same student left and right, but pretty much it's somewhere. Some of the students build the entire electronics in the ground so that all you see is the cool computer on top and the switches to make the numbers. But in the end, we do make a lot of our programs in here after we're done making them in real life, like an actual wiring one. And we do this just for fun, and it just builds just another part of their brain to make this all work, just to see that, hey, we can physically make what you just made in real life. We can make that in a virtual world in Minecraft, so we do that here. Here's really quick, this is the last of our stuff. We build all kinds of stuff that sometimes aren't even part of the assignments. We do them for fundraising or just for fun. So this right here, we did this. This is one of our first projects we ever did. And you'll see some pictures of the girls that did it. It took some hours to do, and it looked really nice at the end. Here's something a student just did on their own time. They came in at lunch or after school and made this, and I took a picture because I thought it was really cool. Here's someone lasered the Laker sign on their phone using the laser. Here's the Jurassic Park when it was all done. I thought it was really cool. This was actually not glued. I just took a picture that's almost complete. We just laid it out to see what it would look like, and it was really neat looking. And here's the girls working on here in the middle. These were freshman students working on that. And on the left, this was some sort of globe laser cut out and screwed together. Inside, to hold it together, are 3D printed plastic pieces. And this is all stuff we made. We made this for a fundraiser for, I think, a baby shower or something to help raise money for our program. These were also things made for fundraisers that people asked for, and we built and made in class. Same thing here. Actually, this one wasn't made by a student. She just graduated and came back because she didn't have the laser cutter when we were here. And she heard about it and wanted to come back. And she came back in one day and made this. So she was in college. She just came back on her spring break and sat in the back of class and made this in half a school day. She designed it, drew it, laser cut it out, painted it, and glued it all in one school day. It was pretty fast. And here's something laser cut on the right side, some Fortnite, I think that was some acrylic with an LED shining in it. Some things made for fundraisers, and stuff made for fundraisers or for fun. Actually, I think the stuff on the right is fundraiser stuff, and these were just made by students for their own house or something like that. So that's about it. You can see we do a lot of stuff in STEM Academy. Kids really love this program. If you think it's right for you, make sure you send me that email that you saw at the beginning of this video, and send me an email, and I'll also have a link to apply to the program as well. It should be sent out along with this video. Okay, so thank you very much for watching.